Welcome to Calculus and Differential Equations, MAT 1103. I am Saiful Islam, a teaching assistant in the Department of CSE at ULAB. You can find my contact details here. This video is about the power rule and rules for differentiation, moving beyond the limit definition to achieve efficient calculation. The derivative is defined as the slope of a function at a point, the slope of the tangent line, and the instantaneous rate of change. The problem with calculating the derivative using the limit definition is that it involves finding the limit of the difference quotient as the change in x approaches 0, which is a significant amount of work. The solution is differentiation, which is the process of computing the derivative. We aim to differentiate functions efficiently using specific rules, such as the power, constant multiple, and sum and difference rules. Here is the notation and language used for derivatives. Common symbols include f prime of x, y prime, and the derivative of y with respect to x. You may be asked to differentiate, derive, or find the derivative of a function. Rule number 1 is the constant rule. Since the slope of a horizontal line is always 0, if a function f of x equals a constant c, then its derivative is 0. Rule number 2 is the power rule. For a function f of x equals x to the power of n, you pull a copy of the exponent out in front and subtract 1 from the exponent. The derivative is n times x to the power of n minus 1. To handle complexity, we have the constant multiple rule, where the derivative of a constant times a function is the constant times the derivative of the function. The sum and difference rule states that the derivative of a sum or difference is the sum or difference of the derivatives. The recommended methodology to avoid errors involves a structured process. First, rewrite the function to power rule format. Second, differentiate by applying the rules. And third, simplify the algebra. Let's look at a case study for polynomials. By following the rewrite, differentiate, and simplify steps, the derivative of f of x equals 5x squared minus 7x plus 6 is f prime of x equals 10x minus 7. For variables in the denominator, such as g of x equals 7 over x cubed, rewrite it as 7x to the power of minus 3 to use the power rule. After differentiation and simplification, the derivative is minus 21 over x to the power of 4. For radicals and roots, like j of x, rewrite it into power rule format. Apply the rules to differentiate, then simplify the expression to get the final derivative. In summary, we have notation, the constant rule, the power rule, and the sum and difference rule. These are essential rules for differentiation. The product rule, also known as the UV rule, is used to find the derivative of a product of two differentiable functions, u and versus. The formula is shown here. The quotient rule, or u over versus rule, is for finding the derivative of a ratio of two differentiable functions, u and v, where v is not 0. The formula is presented here. Here are examples applying the product rule and the quotient rule, showing the breakdown of defining u and v, finding their derivatives, and substituting into the rule formulas to get the final solutions. The final takeaway is to use the limit definition to understand what the derivative means, but use the rules of differentiation to efficiently solve the problem. The limit definition is important for conceptual understanding.